Hello students, good evening. Welcome to Gate Wallah. Hello students, good evening. Welcome to Gate Wallah. My name is 𝐂𝐚𝐿. Welcome to Theory of Computation lecture series. Today is our lecture number 9. And here our name of the topic is same yesterday one, regular language detection, and then grammar as well as grammar. So these two topics we are going to discuss in today's session. Right. So before going to start this, let us see what we studied in our previous session. So yesterday topic is a very important one, regular language detection. Regular language detection. This is what we studied in our previous session. So this is one of the very important one. The name of the first topic is finite automata and regular languages. In that finite automata already we completed. Then we move to the regular language. In the regular language part, the first one is in the topic of regular language, the first one is detection part. Then it will comes to the closure property. These are the main two topics are there in language part. One is detection, other is the closure properties. Right. So in our previous session, we studied some of the important points related to regular languages. Whenever you are detecting regular language, these are the important things. Whenever it is a regular language, whenever it is a concept of regular language, the first one is checking finite or infinite, checking whether the language is finite or infinite. And we studied the relation between finite and infinite as well. The relation between finite language and infinite languages is finite and regular. This is the relation. That's why in order to check whether the language is regular or not, we need to see the given language is finite or not, finite or infinite. Good evening everyone. So some students are asking, sir, can we crack GATE exam in 10 months preparation? 10 months is more than sufficient. Enough time. We have a sufficient time. If you planning is the main thing here. If you plan properly, in 10 months you can crack very easily with a very good rank. Within top 100 you can get a good rank. Right. So finite language, once the language is finite, definitely it is regular. If the language is infinite, so if the language is infinite, what can we conclude about the language? If a language is infinite, it is regular or non-regular? Then both possibilities will come. Sometimes it can be regular, sometimes it can be non-regular. In infinite language, there is no confusion in finite languages. The confusion or the concept is mainly there in the infinite languages. Whenever a language is infinite, sometimes it will be regular, sometimes it will be non-regular. When it is non-regular, comparison exists. Whenever there is a comparison exists, then it comes under non-regular. No comparison exists, comparison not there, language if clearly presents, then it is regular. This is the way we confirmed in the previous sessions. Okay. So palindrome language is also one of the thing. And one more thing is language formed over one symbol. Whenever a language formed over one symbol, we studied some of the questions in the last class regarding that. Language formed over one symbol. What is the concept? Common difference. Common difference exists, regular. No common difference, non-regular. So this is the way we concluded detection of regular languages. So these questions we solved in the previous session. In today's class, we'll see some of this. We'll solve some of these things. I think this one also we studied in the last class. This is non-regular. Non-regular. Assume L1, L2, L3, L4, L5, L6. So L3, what about L4 here? Whenever language formed over one symbol, what is the way of detection of the language? Common difference is the concept. So this is for this, there is no common difference in this, so it is non-regular. All these things are there in previous recording, in the previous class. So if anybody having confusion, anybody missed previous session, please watch the recording of that. You can understand how we solve this. Then L3, what is the L3? The L3 language, if you apply clean closure on this, if we apply clean closure on a power p prime number, then we are getting like this: epsilon, 1a is missing, 2a, after that everything. This is the language of this one. For L3, the type of strings coming is in this way. So we can construct a clear cut DFA for this. Epsilon is accepted, 1a rejected, 2a is accepted, then everything is accepted. So this is non-regular, but this is regular. So that's why L3 comes under regular. Regular. Now let us see what about L5 here. L5, k is even number. Even number, a power k, k is even number. Any common difference there are not there in even numbers? So 0, 2, 4, 6, 9, 6, 8 and so on, even numbers. So if it is even number, common difference exists. This is clearly regular. Like this. So we have some of the important language here. Palindromes. See, whenever a concept of palindrome comes, here there are 4 questions again. Here in this session, I am going to solve some of these, only few of these. Remaining questions, you take them as a homework or solve by your own. If you are not getting, if you are facing any difficulty, please inform me. I'll teach those things again in our class. Right. So what about, come to the third one, even length palindrome strings of English language. Even length palindrome strings of English language. What about that? See, whenever the concept of this thing we studied already in regular expression. Whenever it is a palindrome languages over more than one symbol, if it is a more than one symbol or more than one symbol, palindrome languages are non-regular. Only for one symbol they are regular, more than one symbol are non-regular. That's why palindrome strings not comes under of English language, not comes under regular part. So this is clearly a non-regular language. Next one, fourth one, odd length palindrome strings of Hindi language. Palindromes over more than one symbol, anything, they are non-regular. Right. So sometimes palindromes, the equal number of open and closing parentheses, equality on open and closing parentheses, balanced parentheses. Balanced parentheses means parentheses should be of this one. Here also opening and closing same, but anything is allowed here. Here meaningful parentheses, here any normal parentheses. That is the difference in these two. So anyhow, both are non-regular. Comparison is going on. So this is also non-regular. This is also non-regular. Right. Now we'll spend some time on palindrome language clearly. Today's session we'll spend because palindrome language are very important. Many times asked question in previous papers. So many questions are there regarding palindrome. So the palindrome language generally represented in this way. This is the way palindromes looks like. This is one of the palindrome, L1 we can say, L2, WC W power R, W belongs to A plus B whole star. Even length palindrome, odd length palindrome. We can write, we can see this as even length. Even palindrome, this is odd palindrome. But whatever it may be, whenever, see this is the palindrome, because whenever you say palindrome language are very different kind of concepts, very important things, especially in theory of computation. We'll study this in regular part, in push down automata context free part, in Turing machine REL part. Palindrome language, so it is there in all concepts of theory of computation. Questions also very famous questions came from this. Many number of times asked the questions. Right. See, whenever it is a palindrome, you can take any palindrome. Nitin. What happens in a palindrome is, whenever a string W is there, its reverse definitely presents. That is what the palindrome. If a string exists, if there is a string W, its reverse exists. Let us take one more example. Try to understand the nature of the palindrome. Assume this is the string. A string and its reverse both present in the palindrome. Both should present. Definitely both has to be there. This is the string W. This is its reverse W power R. Middle D is there. So W power R. This is the odd length. That's why there is middle symbol. What happens in the palindrome is, whenever a string presents, its reverse should present. If a string exists, its reverse also should exist. First W exists, then W power R should exist. So a string and its reverse, then comparison is going on. If I take a string as Ni, then after that I cannot take whatever I want. Comparison. This should be depending on this one. Dependencies are there. So the second W completely depends on the first W. W power R means Based on the first W, we will frame the reverse. So once the W is completed, we will frame the reverse. You can observe here. There is a C. There is a separator C. Before C, whatever the string exists. Before C, whatever the string exists. After that, its reverse should exist. Definitely reverse of this. That means dependency. After C, what string we need to generate? If you want to know, then we need to depend on the string present in before C. Dependency. Whenever dependencies exist, clearly non-regular. So comparisons are there in palindrome, non-regular. Non-regular. Right. Now let us frame one question based on this. There are so many interesting and famous questions on these palindrome strings. Let me give one question. This is clear, right? Palindrome strings. Palindrome languages. The question is, which of the following is regular? So this is the question. Which of the following is regular? Here in palindrome kind of this type of languages, almost all languages looking like same. Almost looks in the similar format. But we need to select the correct one. There is a chance of falling into confusions. There is a high possibility of falling into confusions. So we need not fall any confusion. So we need to generate directly here. Correct one. We need to identify the regular one. Which of the following is regular? Right. So here the best way is, if you identify palindrome kind, okay. Otherwise, based on comparison and strings generation, generate the strings. Comparison is going on between the strings or not in the language. This is the way. So what about the first one? I'm solving here. What about the first one? First one is clearly, just now we studied, it's a palindrome. So even length palindrome. Comparison W and W power R comparison is going on. So this is clearly non-regular. What about the second one here? This is also looks like W power R, but W belongs to one symbol. Okay. Okay, right. W power R. W is additional symbol. So this is a clear cut odd length palindrome. odd length palindrome. I want to change the option of this third one. W belongs to A star. W belongs to A star. Then what about this? If W belongs to A star, how the strings will be generated? Find out the strings. Epsilon. We can take epsilon here. Whenever this is A, this is reverse of this. So 2A's. If this from here W, if I take 2A's, 1A, we are getting 2A's. If it is 2A's, 4A's. Reverse also there. W is 3A's, then 6A's, and so on. This is nothing but even number of A's. A star. Regular expression is there. So this is clearly regular. That's why whenever language is looking like same, this is WW power R, this is WW power R. What is WW power R? Palindrome. Palindromes over one symbol are regular. Palindrome languages over one symbol are regular. Palindrome languages over more than one symbol are non-regular. That's why here palindrome over more than one symbol. First option, non-regular. Second one, palindrome, odd length palindrome, more than one symbol, non-regular. What about third one? Palindrome language, one symbol, regular. That's why here which of the following is regular means this is what? Regular language. So whenever you, some students, what mistake generally they do is, the moment they see WW power R, definitely they will say this is non-regular. No, always WW power R kind of language always will not results to non-regular language. Sometimes they can be regular when the language is formed over one symbol. So for one symbol language we studied already in regular expressions as well. For one symbol languages, clearly palindrome languages are regular. That's why we need not to have any confusion over one symbol languages. So whenever the language is one symbol, conclude it is regular. Good evening everyone. Right. Let us see some of the gate questions here. This is the question asked one time in gate paper. Consider the following languages: WW power R, the question is which of these languages are regular? Which of these are regular? We did lot of work on regulars, so I think now we can detect easily what is regular, what is non-regular. This is 2 marks question in GATE, in 1 year GATE paper. So WW, first one is L1 is WW. W belongs to A comma B whole star means A plus B whole star. W belongs to complete language. A plus B whole star means complete language. Second one is WW power R. So he is just saying W power R is a reverse of W. It's not required even known thing. The question is you can consider up to this. Second one is WW power R. Third one is 0 power 2i. I is integer. Fourth one 0 power I square. Third one, fourth one are language over one symbol. First one, second one are WW power R, WW kind of language. So which of this is regular? Let us analyze this. Any answers from student side? The questions, this is a GATE question. The questions generally like this. So this is the GATE coaching. Whatever I am teaching here is GATE coaching. So after completion of topics, we are solving GATE questions. Means you can able to solve GATE questions now. After every chapter, we are solving GATE questions. Right. So what about L4? Let us solve one by one. I square. Whenever language is formed over one symbol, 0 is the symbol here. L4, 0 is the symbol. What about this L4? Whenever formed over one symbol, common difference there are not there. That is the thing we need to observe. Any common difference in this? No common difference. This is clearly non-regular language. Non-regular language. What about L3? What about language L3? 0 power 2i. 2 times. 2 is the common difference in every string. We can generate 2 zeros, 4 zeros, 6 zeros, 8 zeros and so on. So clearly common difference is there. This is regular. This is regular. What about L2? The language L2 is clearly palindrome language. WW power R, a string and its reverse, that too more than one symbol. Palindrome language more than one symbol are non-regular. Non-regular. What about L1? WW. Let us generate the strings. If I take comparison, definitely that to more than one symbol, WW, whatever the first string, the second string completely depends on this. The second string is completely depends on the first string. So if I take AB, first one, definitely we have to take AB once again, WW. That means the generation of second W depends on the first W. Comparison is going on, dependency is there, more than one symbol comparison. Then non-regular. So only comparison concept. Here the major concept is comparison. Where comparisons exist, where comparisons not exist. Comparison exists, we can clearly say that is non-regular. Right. So out of all this, only regular thing he is asking about which language is regular. Regular thing is L3 only. So the answer is D. Here only L3 is regular. This is the question for 2 marks. Similar questions. The questions are like this only. Whatever we are studying in our classes, 90% of the questions in the GATE are almost from our classes only. Similar questions we can able to solve. I am not saying you need to buy hard. So I will give the tips, some tricks and tips based on that, and subject knowledge based on that. We can easily solve whatever the question is coming in the GATE paper by your own. Here by harding will not work in the GATE papers. If you by hard, that will not work. So this is the way. Learn concept in depth properly, apply those concepts to solve questions. Right. Let us solve one more question. Any doubts, students? Any doubts in this? You can ask me. Anybody having doubt in this question, in this GATE question, you can ask me. Otherwise, we will move to the next one. Right. Which of the following are regular set? What is set? Set and language are same. Regular set means regular language. Once again, similar one. All are, is there any finite language in this? In these four languages, is there any finite language? So finiteness checking is a minimum thing. The first thing is finiteness checking. If you check it is finite, if you identify it is finite, clearly regular. So no confusion is there. So we can say directly it is regular. But here what happens? All are infinite languages. Not mentioned by default also language is infinite. Yesterday I told you. If not mentioned anything, finite not mentioned, infinite not mentioned, by default it is infinite language. So all these four languages are infinite languages. Right. Now, what about the first one? A power n, b power 2m. Any comparison in this? Number of a's can be anything, number of b's can be anything. B's can be anything, but it is just a multiple of 2. So if I take a value as 5, b value anything you can take. It is not depends on a value. You can take any number of b's. But whenever you are generating, it is multiple of 2. I can generate 500 b's or 600 b's. Not a problem. M value I am taking 300, so it becomes 600. Like this, anything. So this is independently there, no dependence in the first one, no comparison. So this is clearly regular. Clearly regular. Right. What about second one? So we can rewrite the second language this way. In the place of n, if I take a power 2m, b power, in the place of n, if I write 2m, b power m. Let me write in a clear way. A power 2m, b power m. Any comparison in this? Yes. A's are 2 times of b's. Comparison is going on. If comparison is going on, clearly non-regular. Non-regular. What about third one? A power n, b power m, n not equal to m. Whenever n not equal to m, once again comparison is going on. So this is also clearly non-regular. Non-regular. What about fourth one? XCY. X can be anything from complete language, Y can be anything. There is no comparison between X and Y. So X can be anything, Y can be anything. So here take X value anything, Y value anything. No comparison. No comparison. This is clearly regular. So out of what is the question? Which of the following are regular? Out of all these four, first one and fourth one are regular. 1 and 4 only. So clear one. This is also question, one of the question asked in previous paper, previous GATE paper. Right. Any doubt, any confusion in this? I think all these are dependencies, comparison concepts only. There is nothing new here. Right. Which of the following is true? Easy one. So let us solve one by one. True. He is saying first one, first option. The language A power n, B power n greater than or equal to this is non-regular. But what actually this language A power n, B power n? A power n, B power n is clearly non-regular. Clearly a non-regular language. If it is a non-regular, but what is mentioning here? He's saying regular. So this is clearly false. First option is clearly false one. What about second one? This is the language. All these are known languages for us. From yesterday onwards, we are studying these type of languages. A power n, n is prime. And whenever n is prime, and clean closure is also not there. Whenever n is prime, that too language is formed over one symbol. Whenever a language is formed over one symbol, what is the way of detecting these concepts? Regular, non-regular concept. Clearly it is based on common difference. So in prime numbers, any common difference? No. So this is non-regular. This is also non-regular. But what is giving here? Regular. So this is also false. What about the fourth one? The language L equal to WW. WW and W belongs to sigma star is regular. WW comparison. This is non-regular. Non-regular, but he is saying regular. This is also false. Third one, W has 3k plus 1 b's for some k. So number of b's are 3 multiples of this. W has 3k plus 1 b's for some k, that's all. W is multiples of 3, but there is no comparison with A's here. Number of A's, B's comparison not there. So this is clearly regular. Regular, so this is true one. The true correct option is C. This is also one of the question asked in the previous time. Let me give one more question. Which of the following is regular? L equal to WW power R, W belongs to A plus B whole star. I can take some X here. X WW power R and X belongs to A plus B whole plus, and this is also belongs to whole plus. WW power R X, W comma X both belongs to A plus B whole plus. Both belongs to A plus B whole plus. So all these are the four options. Which of the following is regular? See these languages. All these languages looks almost like same, but clearly there is only one regular language in this. There exists only one regular language. So this is a like a homework question for you. 1 year gate question, 2 marks gate question. What is which of this is regular? Find out. So what is the correct answer for this? Write in the chat session in the next class. So x w power r wx both belongs to a plus b positive closure. W power r x wx both belongs to a plus b positive closure. Wx w power r both belongs to positive closure. W belongs to positive closure. So which of the following is regular? There is definitely one regular language in this. Some remaining are non-regular. 3 non-regular things are there, 1 regular thing is there. Which one is that? We need to find out. Okay. Right. So these are some of the tricky questions. These kind of things generally they'll ask in papers. So you try by your own. If you are not getting, I'll explain this in the next class. Okay. So now let us move to, with this regular language detection is completed. Our next topic, grammar. So with the previous thing regarding regular languages, almost all the concepts we have completed. So very important one. That's why I have taken this much of time. Almost 2 hours time we spend on this. Almost all the major languages I covered. There are so many other tricky things. We'll see those things in the coming classes. So anyhow, today's topic is a grammar. We'll start from here. Grammar is one of the very important concept of computer science. Actually, this concept is a common concept. This topic is clearly a common topic for 2 subjects. One is theory of computation, one is compiler design. So for these 2 subjects, this is a common thing. You cannot touch any question of gate compiler design questions without grammar topic. Without the knowledge of grammar topic, this is very difficult to solve any questions of compiler design, because every question is almost related to grammar topic, and that grammar topic is actually one of the concept belongs to theory of computation, right? So that is the topic we are going to study now. First, let us see what is the grammar. Why this is that much important here? Why this is having that much important role in computer science? Because computer science is all about languages. Whenever we say computer science, we are studying from our first year onwards C language, C++, Java, this language, that language. Whenever the concept of language is there, definitely grammar follows it. Because see, in your childhood, you might have studied English language, English grammar. Everybody felt some difficulties, something, some learned grammar of that. Then anybody studied Hindi language, then they might have studied their grammar, Hindi grammar. If anybody studied some other language, then it's grammar. So whenever you say language, grammar exists. Like this, we have grammar for C language, C++, Java language, Python. For everything, grammar exists. So to construct compiler, so compilers are constructed on the language grammar rules. Whatever the, for every language, grammar exists. Java compiler, take the Java grammar, on that construct a compiler. So this is the way generally compilers are working. Compiler design is happening, right? That's why grammar is one of the fundamental and very important concepts for computer science students. What exactly this grammar? Grammar is nothing but, what is a grammar? Anything, normal definition like English grammar, anything. Set of rules used to describe strings of a language. Set of rules used to describe strings of a language known as grammar. Grammar is nothing but just a set of rules. That's all. Everywhere that is a grammar. Grammar means rules. But here these rules looks in a different way. So generally the grammars of this here looks like this. Here rules we don't write directly. Rules written based on some notation, that is called as the general formal definitions. This is the normal definition. Grammar is generally represented with 4 tuple. All our grammars, C, C++, Java, these grammars or computer science grammars looks in this like this notation. This is called as NTPS notation. NTPS notation. We have non-terminals here or variables. We have terminals, number of productions, starting symbol. Let me analyze NTPS on this. Right. This is a grammar. This whole thing is one of the grammar, example grammar. Every grammar having these 4. Grammar is a collection of 4 things. Grammar means non-terminals. Computer science grammar, whenever you are studying grammar, we have a non-terminals or variables. We have terminals. We have productions, starting symbol. See, first let me explain what is a starting symbol. In any grammar, the first symbol whatever is there, that is a starting symbol. Very simple, easy one. So starting symbol I cannot write anywhere. Starting symbol should be in the top of the place. So what is the first position? Symbol S. So starting symbol of the grammar will be S. So I am writing here only the starting symbol of this grammar is nothing but S. Then let us see non-terminals. In general, grammars are written like this with the help of alphabets, small and capital letters. In general, all the capital letters are non-terminals or variables. So here for this, non-terminals or variables will be then terminals. In general, small letters or small letters whatever is present here, those comes under terminals. So the general notation of this will be this one. Then every grammar is of the form, all grammars is of the form alpha derives beta. This is the format of the grammar. There is some arrow in the middle. There is some arrow. So left of this alpha will be there, right of this beta will be there. So left some terminals, non-terminals, some terminals, non-terminals, like this. This is the grammar structure, grammar format. Right. So this is pronounced as alpha gives beta, alpha tends to beta, alpha derives beta. These are the terminologies generally used. How many number of arrows will be there? This arrow indicates a production. So number of productions is nothing but how many arrows will be there here. That is a production. So here the meaning of this one is A gives A gives B. So how many productions here? 1 production, 2 production, 3 production, 4 productions. So total number of productions will be 4. So this is our NTPS analysis on this example grammar. So grammar is nothing but rules. The rules will be represented in this way by using 4 tuple: non-terminals, terminals, productions, starting symbol. Generally what we have to do is we need to construct grammars. According to our rules, we need to construct grammars by using this. This is the way I constructed one of the grammar, example grammar. Then for every language, grammar exists. Whenever you say language, grammar exists. And for every grammar also represents one language. For every language, grammar exists. For every grammar represents one language. Right. Now the question is, for one language, how many grammars exist? So the meaning of this one is, let me say, I am speaking about formal language only. This is the language. Remember this statement: for every language, definitely grammar should exist. Without grammar, language does not exist. Language grammar equivalence is there. This is the language. You forget about DFA possible, not possible. We are not in the session. We move out of the regular part. So this is a language. For every language, whether it may be regular, whether it may be non-regular, grammar exists. So if I want to write the grammar for this, the grammar looks like this. If you are feeling difficulty, then let me write in this way. So this is the grammar. So for this language, this is the grammar. Like this, whenever you say language, grammar exists. Now the question is, how many kind of grammars, how many grammars exist for this same language? Only one or many? So we can construct so many number of grammars. Only one is not compulsory here. So many number of grammars can be constructed. We can construct for the same language one more grammar. We can construct 2 grammars. We can construct 3 more grammars. Like this, any number of grammars can be possible. Unique for one language, unique grammar will exist. There is no concept like that. That's why in the construction time, whenever you are generating, different people can generate different grammars. All they are equal. And here minimization of grammar also not there. So no issue. One, then reverse concept. If a grammar is given, we need to generate the language from the grammar. Then how many languages possible? If you want to generate a language from the grammar, how many grammars possible? Then it is only one. Multiple things is not allowed here. So if you want to generate a language from the grammar, that is only one thing. Right. Now the question is how to generate. The construction of grammars we will see in the coming classes. In today's session, let me explain the generation of language from grammars. How to generate these languages from the grammars. For that, we need to use a concept called as derivation. Derivation. So derivation, the process of deriving strings from the given grammar is known as derivation. The process of generating strings from the given grammar. This derivation can be either leftmost derivation or rightmost derivation, or we have one more form called as derivation tree. Derivation tree. So derivation, the derivation tree is the famous one. So in today's session, let me explain the derivation tree for some of the examples. Derivation tree or parse tree. Derivation, representation of derivation in tree structure is called as parse tree. There is nothing else here. So known as parse tree. all leaf nodes or yield of the parse tree. Okay, anyhow, let me take one example. Same grammar, take the previous one. Derivation tree both are same. The more important thing is the derivation tree. So most of the time we will generate the derivation trees. We'll see here. Anyhow, let us see how the derivation tree for this is the grammar. I want to construct the derivation tree for this string AAB. Parse tree or derivation tree. Parse tree or derivation tree. How it will be constructed? Start from the starting symbol. To start from S, take its production, right side production. Take any start symbol, generate its right side production. Again, next we have all the non-terminals will be expanded. Terminals production is not there, so no need. All the non-terminals will be expanded until every leaf nodes becomes a terminal. Till this. Again, S will be expanded. So S, in order to generate this, S is replaced by AB. So now just read the leaf nodes only leaf nodes. So our required string is generated, AAB. So this is called as the derivation tree or parse tree. Right. If I want to write the derivation for this, for the same one, same replacements, all these replacements represent in the form of just a step-by-step process. Representation of derivation in the step-by-step process is called as derivation. So generally start from S. Same thing, S will be replaced by ASB. Again, this S will be replaced by AB. S is replaced by like this. S is replaced by. That's all. This is called as derivation. There is no difference between the derivation tree and derivation. This is parse tree, also called as derivation tree. So here major concepts in grammar is, one is construction of the grammar, how to construct the grammar for the given languages. Previously I constructed. I'll explain you how to construct those. I know directly, that's why I constructed. I'll explain for you how to construct this grammar. That is one thing. Next one is derivation, way of generating the derivations, parse trees. So once if we are able to generate this, then we'll perform ambiguity handling, then simplification of grammars, so many things. So ambiguity checking is one of the important thing that also will perform by using in this derivation tree concept based on this. So for every language, we'll say in the coming classes we'll see more elaborated on this, how the derivation trees, we'll construct derivation trees for larger grammars, large class of grammars. Then we have 4 grammars here, 4 types of grammars: regular grammars, context free grammars, context sensitive grammars, unrestricted grammars. So here in theory of computation we are going to study 4 types of grammars. Regulars, for every language grammar exists. We are studying regular language, regular grammar. Context free language, context free grammar. Context sensitive generally not there for syllabus anyhow. Unrestricted grammar, also called as REL, for RELs, recursive enumerable languages or recursive enumerable grammars. So corresponding automata, Turing automata, linear bounded automata, pushdown automata, finite automata. So studying about all these, we'll take one by one. Take regular grammars, construction of finite automata, regular expressions. Take context free grammars, construction of pushdown automata, context free languages. Unrestricted grammars, construction of Turing machines. This is the overall concepts of grammar. So this is what we are going to study in our future classes from grammars. Okay. So this is our plan, students. In the coming classes, we are going to study in this structure. Okay. So that is the introduction today. That is the introduction regarding grammars, as well as we completed regular languages. And next class onwards, we will continue on grammars in a depth way. So we'll see so many concepts related to grammars. Okay. That's all about today's session. Thank you. See you in the next class.